Here's your state transition table, your transition function, delta, and written here in the form of a table, presuming you know how to read this. So if current state is Q1 and input symbol is 0, transition to state Q1. So Q1 naught to Q1, Q1 naught to Q1. So Q1 naught to Q1. Okay. Now remember the state transition table or the transition function is implicit in your state diagram. Or we can go the other way. I mean they're equivalent, right? Or this way is explicit. You know, it's spelled out, but this way it's implicit. But you can deduce the state transition table from your state diagram. Okay. Let's do another one. Let's say if the current state's Q3 and the input is 1, go to Q2. So Q3, 1, Q2. Q3, 1, go to Q2. So that's this transition here. Okay. So there's your that's a table for your transition function. So your delta, okay, there it is. Now 4, start state just Q1 here, and 5, well there's only one accept state, and that was Q2. So it's a set with one member, okay, so Q2. Alright, now I've mentioned this a little bit before, but bring in a new terminology now. So this automaton can accept probably lots of different strings. Okay, so put all those strings into a set. Label that set A. Okay, so it's the set of all the strings that this. Well, we're not talking about M1. I was just talking general. An automaton, M, any machine, any automaton, and just label it M generically. You know. So a machine M. So A is the set of all the strings that machine M, that automaton M, accepts. Okay. So and now the set of all accepted strings, by definition, you know, from earlier, is just a language, right? So we're labeling that language A. So A is a language, set of all accepted strings, right? And you can write so you can. This is another way of saying the same thing. Is that A, in fact, is the language of machine M. So I mean, think in terms, what does an automaton do? What's its function? Its job? Its job is to recognize a language. And what does that mean? It's if an automaton recognizes language A, what that means is, you spell it out in more detail, it means that every input string of that language is accepted by the automaton M. Okay? Every member of that set. And remember, a language is just a set of strings. And in this case, accepted strings. Okay? So A here is the language of machine M. And you can write it this way. So L of M, so the language of M is A. Okay? So the language of M is A. So L of M is A. So if you see this, you just in your head translate it in your head as so the language of M is A, and that means that this automaton, this machine M, its language, in other words, the set of all input strings that it accepts, is A. Now you don't know what A is. Depends, you know, but if you're given what the language is, you're given a description of all the input strings of A that this machine M accepts, then you know the job of the automaton. You know what the automaton's doing, right? It's recognizing that language. It's accepting all that language's input strings, all its members. Okay? Now, instead of saying that the machine accepts the language, that creates ambiguities, because we've been using this word accept for what the automaton does to a string. Okay? A string, a sequence of symbols. So let's use a different word. So let's say the machine recognizes the language, okay, and the machine accepts an input string. Okay? So otherwise, if we use the word accept for those two uses, it's just going to create ambiguity and confusion. And yeah, so let's say so the machine recognizes a language, but it accepts a string. Okay? So in the context of string, use the verb accept. In the context of a language, the whole set of accepted strings, use the verb recognize. Okay? Alright. Now see what I mean? So now a machine can accept several strings, right? It doesn't have to be just one, a whole bunch of them. It could be an infinite number of strings that the machine accepts. Okay? So a machine can accept several strings, but recognizes, I'll put it in here, recognizes only one language. That's almost, do you know what the word tautology means? You can deduce, if A then B, if B then A, that's a tautology. Because you define the language as all those strings that the machine, the automaton, accepts. Right? Now, that's still true. For example, say the machine accepts no strings. For example, say the automaton has 0 accept states. Okay? So that means every string that goes in will be rejected, because it's impossible for that machine to accept anything because it doesn't have any accept states. Okay? So the language that that automaton accepts in that case is the empty language. The set of with no members. And what are the for a language? What are the members? Well, accepted strings, but no string is accepted in this case. So you'll have an empty set. Well, that's what this symbol means, the empty set. And that's like a language with no members, with no input, with no accepted input strings. Right? Okay, now, so that was a fairly quick session. Now, now for the next session, we'll go back to our M1, and we'll actually talk a little bit about just exactly what language that M1 recognizes. Okay, in a bit more detail. So we'll write L of M1 equals A. A is your language, but what is that language? What properties do the input strings have that make them members of that language A? All right, and then we will start. We'll start doing some other examples of automata, different from M1, right? And we'll do a whole bunch of them. I usually say a whole string of them. I can't say that in this context, it's confusing. So we'll do several different automata and write out their 5-tuple, their formal definition, to give us practice doing that. Okay, so.